Good evening, friends. Now, by the last video, I had finished all the concepts related with congruency. Okay. Now, in this video, we will try to look at the application of congruency. Okay. Now, let's start off with the triangle. Suppose that if I have any arbitrary triangle, let's label it as A, B, and C. Now, what is given to us that AC is equals to BC. Now, this is given that AC is equals to BC, or we can say that length AC is congruent to length BC. Okay. Now, we know from our childhood classes that in a triangle in which at least two sides are congruent, then that triangle is known as isosceles triangle. So this is ABC is an isosceles triangle. Okay, isosceles triangle. Now let me introduce some of the terms related to the isosceles triangle. The two sides which are equal to each other are known as legs of the triangle. Okay, so AC and BC are basically legs of the triangle. Now the third side which is not equal is known as base. So AB is the base. Okay. Now the two angles, these two angles which are formed by one equal side and the other side is known as base angle. So this is a base angle. Okay. And these two the legs of a triangle, they form an angle which is known as vertex angle. So angle C is vertex angle. Okay. Now what we have to prove in this video is to prove that this base angle CAB is congruent to angle CBA. This is what we have to prove. Now, well, we don't need to worry as long as we have in our toolkit the postulates or the theorems of congruency. Okay, but to apply congruency, we have to have two triangles. No, so let us construct two triangles out of this one triangle ABC. Now, if you find out a point which is the midpoint of AB, say this is the midpoint of AB, and if you join the vertex C with the midpoint AB, okay, so this is the midpoint of, okay, one second, that is not, okay, this is the midpoint. Okay, this, let's call this point as D. Okay, now we know that D is the midpoint, therefore the distance from A to D and the distance from B to D will be equal, therefore AD will be equal to BD. Now if you look at the triangle, ACD and triangle BCD, and let's compare the sides. Now AD is congruent to side DB, okay, AC is congruent to side BC, and this side CD is shared by both the triangles, therefore by SSS postulate we can clearly say that these two triangles are congruent. This triangle BCD, let me make it proper, BCD. So these two triangles are congruent by SSS. And once we have proved that these two triangles are congruent, then their angles and their sides will necessarily be congruent. I mean their corresponding sides and angles will be congruent. So from here we can say that the angle CAD will be equal to or congruent to angle CBD. So we have proved what we wanted to prove at the beginning, that the base angle are equal. Okay. Now let's prove other way around. That if base angles are equal, then the side opposite to them are equal. I mean, if two angles are equal, then the sides opposite to them are equal. Now this is what we have to prove. Okay, so let's prove. Now we are proving other way round. In this triangle we prove that if two sides are equal, then the angles opposite to them are equal. Then angles opposite to them are equal. And now what we have to prove, that if two angles are equal, then the sides opposite to them are equal. Now let's form another triangle, and let's label it as A, B, C. Same labeling. Okay. Now in this video what is given to us, that this angle is equal to this angle. What is given is angle CAB is congruent to triangle CBA. So if angle CAB is congruent to angle CBA. Okay, this is given to us. Now what we have to prove is that the sides opposite to them are equal. That is BC is congruent to side AC. Okay, side AC. Now again, there is no need to worry as long as we have in our arsenal, in our toolkit, the theorems of congruency. Okay, but to apply congruency, again we need to have two triangles. So here I will choose a point such that if you meet the vertex C with this point, then this will be perpendicular to this. Okay, or you can say that drop a perpendicular CD to the side AB. Okay, now CD is a very straight line to the side AB. Okay, you have dropped a perpendicular from the vertex C to the base AB. Okay, now again, if you focus at the triangle ACD and triangle BCD. Okay, now angle CAD is congruent to angle CBD. Similarly, this angle is congruent to this angle, 90 degree, and the side CD is common for both the triangles. Therefore, by AAS, we can say that these two triangles are congruent. Therefore, if two triangles are congruent, then their corresponding sides and their corresponding angles will also be congruent. So from here we can say that AC is equals to BC. Okay, and not only this side will be equal to this side, because these two are the corresponding sides, but AD will be corresponding side to the side DB. Therefore, AD will be equal to BD. So this will be equal to this. So I mean, there is an extra information that we are getting, that CD, which was perpendicular for us to the side AB, turns out to be the perpendicular bisector. Okay, so the perpendicular dropped from C also bisects the side or bisects the base AB. Okay, again you can, from here we can also see that angle ACD will be equal to angle BCD. Therefore the perpendicular bisector also bisects the angle. Therefore this perpendicular is also the angular bisector of the vertex angle C. Therefore CD is also the angular bisector of vertex angle C. Okay, so I mean, these are the very useful information that we have just discovered, and we will be using these information in the later videos where these information will come very handy for us to solve the problems. Okay, so that's it for today's video. In the next video we will see some more applications. Okay, thank you.